Okay, so let's just get this party started. Let's look at, right, on screen one, want us to sort of set the stage. What is our goal for today? So yesterday we were introduced to three new trig ratios, right? They were just the reciprocal of the three that we already know. Okay, so and yesterday we were just drawing pictures and whatever, but everything was basically positive. Like all of the side lengths were positive. Well, we know that if you put a triangle on the coordinate plane, like we did on the unit circle as an example, that you can actually have side lengths that are negative, or you can have like sine and cosine that are negative. We know that, right? We've seen that already. So if you can have negative sine and cosine, negative tangent, you can have negative reciprocals of all those too. So today we're just going to sort of learn about how we can represent these reciprocal trig and their regular trig ratios on the coordinate plane, and where would they be positive versus where they'll be negative. Okay, so that's what slide 2 is supposed to be getting us to sort of think about, right? We're really reinforcing, I'm going to anonymize you all here. We're really reinforcing this connection that cosine is x and sine is y. That's got to stick in your mind. I'm telling you, if you're taking calculus next year, cosine is x, sine is y. It'll come back to you, okay? So I'm asking you, like, okay, well, where is cosine positive? Put a C there. Where is sine positive? Put an S there. And then where is tangent positive? And that's might be the one that you have, the least comfort with. We really don't do as much with tangent as we do with the sine and cosine, but tangent will come more to the forefront in the next, this last unit. You'll see tangent probably a little bit more. Okay, so if we're noticing like what people are putting, I can overlay them all, make a hot mess out of this. Ooh, okay, but it's still good. We can see that mostly everybody has everything in here. There's C's in here, there's S's in here, there's T's in here. Because this is positive, positive. So everything is positive in quadrant 1, right? I call it Disney World. Everything's positive. Nothing negative there. So if cosine's x, he's positive, sine's y, he's positive. And now here's what we need to make sure you remember. And if you don't remember this, you need to put this in your notes. I'm just going to choose a random person, and this random person, you're going to have stuff in your feedback because I'm just going to take notes. So what you have to remember, and you might know already, okay, tangent is sine. Look, I can just type theta and theta comes up. It's so cool. It's sine over cosine, or think of it as y over x. So you have to know that. It's not been used a ton, but it's going to be used more and more and more. So if you need to write that in your notes, write that in your notes, okay? So if we do sine over cosine, we'd be doing y over x, positive over positive, tangent will be positive here. All right, again, so we know sine is y. Y is positive if you're above the x-axis, right? So sine's going to be positive here and here. And again, look, y is positive, sine's y. So sine's positive here and here. Cosine's positive if you're on the right-hand side of the y-axis, right? Positive x, cosine's positive. All right, and then tangent is positive here, like we said, because everything's positive there. And tangent's positive here as well, because we're doing y over x. You're going to do negative divided by negative. Negative divided by negative is positive. So tangent's the only guy that's positive here, right? This idea of where things are positive and where things are negative is going to like dominate like much of what we're going to do today. It's really going to be foundational. Okay, so you might, well, I don't know. Okay, so I think that you can keep that straight, I guess, if it helps you to put this plus, minus, plus, stuff like that, when you draw a coordinate plane, it helps me keep straight, like where's what is positive. All right, so now let's go on to the true false section. Okay, so if cosecant is negative, then sine has to be negative. Is this a true statement? It is true, because yesterday we learned that sine and cosecant are reciprocals of each other. So if you have a negative fraction and you flip it, you still have a negative fraction. All right, the sign doesn't change, it just flips. -1/2 and -2 are reciprocals of each other. -7/8 and -8/7 are reciprocals. So if one of them is negative, the other one's negative. So if we go back here and we say sine is negative down here, well then guess what? Cosecant is going to be negative wherever sine's negative. Okay. All right, the reciprocal of -1 is indeed -1. We talked about that yesterday. He's his own reciprocal. If you flip him, he's still -1. Right. The reciprocal of 0 is not 0. It's 1/0, which is undefined. So the reciprocal of 0 is undefined. Great. And then yesterday we spent some time talking about this idea. If you say 1/something, 1/anything is the reciprocal of that. So 1/, -2/3 is indeed -3/2. Okay, so that's like it. Obviously, we'd rather write -3/2 than 1/, -2/3. Right? Triple decker fraction, not so attractive, like almost never seen. So 1/anything is the reciprocal. And then this last one is also false. It says cotangent and secant are both negative in quadrant 3. Well, we just showed that tangent is positive in quadrant 3, right? So if tangent is positive, cotangent is positive. Right? If tangent is sine over cosine, or y over x, cotangent is just going to be the reciprocal. It's going to be cosine over sine, or x over y. So if I do x over y, still going to be negative divided by a negative. All right. All right, so this is very well done, Vihart, whoever you are. Okay, so now I'm going to open it up to slide 4. Right, so here's what I'm going to ask us to do to sort of try to navigate this. We're going to do slide 4 like together. I want to ask you to sort of stay on my tab while I sort of talk us through some things, and then I'm going to ask you, it sort of reminds me when we were filling out our unit circle at first. I'm going to ask you, like, okay, watch like me do my little explanation and then draw it in your Desmo screen. But then you're also going to want to draw these examples in your notes. You're going to want examples from screens 4, 5, and 6 in your notes, because when we come back from break, it'll be just so nice to have them written down in a nice orderly way instead of having to open up old Desmoses and look at them and stuff. Okay, so have your notes ready. So slide 4, it's asking us, it says sine of theta. We're just going to do this left-hand side first. Sine of theta is 4/5. Which quadrant could this be true? So you might already have ideas and have your brain might be working. I know where it could be true. You might be onto something. That's great. I'm just going to sort of, for the sake of time, like model my whole thought process. I'm going to like rough draft think right out loud for all to hear. So when I see sine, I'm thinking y. Where could my y be equal to 4/5? Right? Well, I'm more concentrating on the fact that this is positive. It's a positive number, 4/5. So what quadrants could this be true in? Well, where's sine positive? Here and here, right? Sine is y. Where's y positive? Here and here. So what I'm going to do is I'm going to sort of say it can't be here because my y is negative here. And it can't be here because y is negative here. So it could be here or here. Now what we're going to do is we're going to take this a step further, and we're actually going to like represent this with a picture. Okay, we're going to draw in the triangles. And when I draw these triangles in, I'm really not harping on being like persnickety about drawing on the scale at all. I'm just like drawing a triangle, but I'm going to tell you some strategies for drawing these triangles, because there's really a right way to draw it, and there's only really one right way to draw the triangle. okay? First off, you want the hypotenuse of your triangle to come out from the middle, like it's a radius, even though there's no circle here, but it's like a radius coming out of the middle. And then you're going to draw the y side. And we want this to be a right triangle, so boom, right triangle. Okay, and we said we could have the same thing going on in this. I'm going to try my best to make these look somewhat similar in size. They should actually like be congruent triangles. So do your best to make them similar in size. Okay, so I drew my hypotenuse. This guy looks smaller. I feel a little disappointed in myself, but I'm not going to worry about it. Okay, and draw your hypotenuse like he's a radius, and then you draw your y side. And now we're going to take the fact, I'm just going to write this here, sine. You don't have to write this on here. You could write it when you write it on here. So that we know the sine is 4/5. Then what do we know? The 4 and the 5 are two sides of my triangle. The 4 is going to be my opposite side, and the 5 is going to be my hypotenuse, right? Okay, so our angles are always these central angles here. So the opposite side is 4, and the hypotenuse is 5. Here, the opposite side is 4, the hypotenuse is 5. Okay, so I'm going to say something else that might be worthy of writing in your notes. Your hypotenuse is always going to be a positive number. Always, always, always. The hypotenuse will always be a positive number. Because you think of the hypotenuse, again, like it's a radius of a circle. So you can't have a negative radius. The hypotenuse is always positive. Your x's and your y's can obviously be positive or negative. You know, that's what the whole coordinate system's about, is having positive and negative x's and y's, but not the hypotenuse. He's always positive. Okay, so that picture represents like the two places. And again, on here we could still think like this is being 0 degrees, and you know, whatever this angle is here, we would still think of this being 180 degrees. And so this angle would be like, I don't know, however many degrees away from 180, 90s at the top and 270s at the bottom. It still sort of works the same way, okay? So there's two different places where you could have an angle whose sine is 4/5. And that's the picture. All right, I'm going to say something, I'm going to add something on right now that we're going to do more of when we come back. But if we wanted to go ahead and do Pythagorean theorem and find the missing side, many of you probably already know the missing side's 3, right? Because there's a 3, 4, 5 makes a right triangle. 3 squared plus 4 squared equals 5 squared. So a lot of people like know that automatically. But if you didn't and you did Pythagorean theorem, you would come up with the third side is 3. But if we were doing that, if we were going to label that on here, we would label this side 3. But this side, you'd have to get labeled -3. You see that? Because he's got a negative x. If you're in quadrant 2, you have a negative x and a positive y. All right, so how would the picture look different if the sine was -4/5? So when you guys, you can go ahead and try to copy my picture. I'll leave it up here. You want to get the same picture in your notes, and then try to do the second side if you haven't. Some people might have already started to try to do that. I'm going to leave this screen up though, and get this first half down in your notes and on your screen, and then go ahead and try to do the right hand half and see if you figure out how you would label that guy. Okay, and it's okay to be, like I said, in rough draft mode. This is the first problem that we're doing. Okay, let's see how we're doing here. All right, I'm pulling up Mariam Mirzakhani's. Okay, so this is a good picture for the supposed sign is negative fourth fifths. I have this up in Teams, and this is drawn perfectly. So again, it's not an art competition, so don't spend a lot of time. And if you're drawing it in your notes, probably only need like 4 lines or so, 4 or 5 lines to get it drawn. But I don't know if you're looking on my tab or not, but notice, like, again, the 5 is your hypotenuse, so it has to be positive. And hopefully it makes sense that the 4s would be negative because you're going down, the sides are going down in direction, so they should be negative. And I sort of like that Miriam took this extra step to throw the 3 and the negative 3 on there. Because, if you're in quadrant 3, you're negative, negative. And if you're in quadrant 4, you have a positive x and a negative y. All right, so what I'm going to ask you guys to do right now is if you have this like in your, I really want you to have it physically written on paper somewhere. So if you have this in your notes and on your Desmos and you're like, okay, we're ready to move on to the next slide. When you're ready for that, raise your hand and then I'll know like we can go on to the next slide. Because there's several people already. And I'm hoping it's making sense. I mean, I started out with sine, which everybody's, even if you weren't here yesterday, you're familiar with sine, because that's a very familiar trig ratio. All right, let's see how many people we got. 12 people with their hands, 11 people with their hands raised so far. Okay. So we'll do another like 30 seconds, then we'll move on to the next one. Trust me, you'll be glad you have these examples written down. All right, well, we're gonna move on now. So you can unraise your hand because we're obviously gonna repeat this process on the next screen. Okay. All right, so on the next slide, let's look at this. It says secant is equal to 4. So secant's one of our new guys. If you weren't here yesterday, you're like, what is that? So we're going to do when secant's positive 4, and then we'll juxtapose that. Look at me using literary terminology. We'll juxtapose that with secant is equal to negative 4. So to be nice. So let's think about where's secant equal to 4. So if I was doing this, let me go, hold on. Of course my phone is going to ring, and it's going to be somebody telling me that my car insurance just expired, or my car warranty. That's what they try to tell you. I unplugged it. All right, let's look. I'm just going to pick somebody's slide to go on because this way I have this feedback box I can write into. I'm going to write in the feedback box just because that's a good place to take notes. So secant of theta, it says, okay, that's what it tells me. You know what that means to me? Secant of theta is 4. All right, I think, all right, well, secant is the reciprocal of cosine. I have that in my notes from yesterday. So now that tells me I know that cosine of theta is equal to 1/4. Now, I don't have to take that step first, but I would say almost 100% of people would rather work with cosine than secant. You're just so much more comfortable with it. All right, so my next step is, all right, cosine is 1/4. I'm thinking cosine is x, and 1/4 is positive. It's a positive number, so I need to figure out where the heck is cosine going to be positive, because that's the quadrants where this could happen. So x is positive, and on the right hand side, we already said that on slide 2. So I'm just going to cross out these two. I know it's not going to be in there. I don't even want to draw my triangle there because that x is negative there. So now I need to draw my stinking triangle. I'm going to draw it the same way. First, I'm going to draw my my hypotenuse, like he's a radius. Try to draw it, in a similar way. And then I draw my y side. So if cosine's 1/4, I'll come back up in here. Then that's my adjacent, she said. Right, it's adjacent over hypotenuse. So that means my adjacent side is 1 and my hypotenuse is 4. I'll put my hypotenuse on first, gotta know which one's my hypotenuse. Does that look like a 4? Oh my God, it looks like a Y. I totally drew a 4, I'm telling you. All right, my hypotenuse is 4. And my adjacent side, again, here's our angles. Adjacent side's here, 1. Like, I don't know if you want to write it twice or not. You really don't. We like to share that side, right? The adjacent side is positive. This is a positive x, positive hypotenuse. If you wanted to do the Pythagorean theorem and find the third side, you could. Just be mindful that this one would be positive y and this one would be a negative y. Here's our little right angles. I'll put them in there. Okay, so I'm going out on a limb and trusting that you all know how to do the Pythagorean theorem. And so this one would be square root of 15. Okay, I'm writing like I'm like kindergarten. Trying to write nicer. And this one would be negative square root of 15. Okay, I just got that doing the Pythagorean theorem. Nothing, been doing since probably 8th or 9th grade. Okay. All right, so there you go. So you got your positive y, positive x in quadrant 1. You got your negative y and your positive x in quadrant 2. And there's our beautiful picture. So what do you think would look different if you had secant is equal to negative 4? See if you can't draw it on your Desmos. And then also draw it in your notes. Okay, you can unraise your hands from last time and then raise your hand, re-raise your hand once you feel like you got it for this time. And I'll definitely go over it to make sure that you have it right. I'll leave this picture up in case you still need to look at it. We only have one more to do, guys. And I'm guessing you could probably anticipate what it's going to be. Right, I'm gonna see how many hands we got up. So we got people drawing, which is fine. I'm gonna look at and see what people's pictures look like. Because some people might be drawing like, oh, I'm not so sure. Because we're in rock trip. All right. We'll look at Girolamo Cardano's. So this one's nice, right? This looks good to me. So secant is -4, so cosine is -1/4. And again, you know, you might be thinking like, oh, does the negative have to go with the 4? Like it looks like the negative's with the 4. When I flip this guy and I get 1/4, you know that 4 is your hypotenuse. The 4 cannot be negative. I told you that the hypotenuse is always positive. If you think of it like a radius, you can't have a negative radius. Okay, so that means the negative has to go with the 1. And if we're in these quadrants over here where x is negative, cosine is x, then it makes sense that our x is going to be negative. So this one's drawn very well. A very good job, Girolamo. And I'm sure other people had theirs just as well. So this is a nice one if you're like feeling a little iffy about it, to maybe copy that one down in your notes. Okay, and see if that still have a few people without hands up, so that's fine. You're getting it in your notes because we have one last one to do. So again, once you have this, and if you have questions, ask them. Nobody's going to get mad and like, oh, you're holding us up. It might be just something like some little thing that's bugging you that would take like literally seconds to fix. You all okay out there? No questions? Okay, so we got 8 people with their hands up. See, if we were on person, I could be walking around checking, and then you could say, Miss Wilson, why did you know that the 4 isn't negative? Oh, because it's the hypotenuse. Oh, right. I said you should write that down. But I don't know what you're doing. I highly suspect that there are probably people out there writing this stuff on the back of a napkin or God knows where, writing it on the envelope from a Christmas card. Okay, so just have a couple more. In like 15 seconds, we'll move on. And if anybody needs me to go back, I can always go back. But I'm 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so let me open up the next slide, and it's going to be our last one. So you can unraise your hands because we're going to need to raise your hands. All right, so let's look at this one. Okay, cotangent is 5/12. All right, cotangent is 5/12. It's somewhere little. So now, I'll put David Hilbert. David Hilbert. Okay. So cotangent is 5/12. What's that code for? That's code for tangent is 12/5. All right, that's positive tangent. So we think to ourselves, where is positive tangent? So positive tangent, everything's positive in quadrant 1. And then the other one must be in quadrant 3 because that's what tangent is also positive. So we don't want this quadrant. I say we don't want this quadrant. And we don't want this quadrant. This tangent's negative there. And so what am I going to do? I'm going to draw my triangle. So first, draw your stinking hypotenuse. Draw your y side. Okay, and then I'm going to try to draw one pretty similar to it. Draw my hypotenuse. and draw your y side. These are the two quadrants where tangent is positive. Okay, so we got 12/5. So we know tangent is, oh, somebody's in the lobby. Let's see, who's in the lobby? Brooke must have gotten kicked out. All right. She's back, everybody. Okay, so we know the tangent is opposite over adjacent, right? Toe up, opposite over adjacent. So 12 is our opposite. Well, here's our angle. It's always in the middle here. Opposite. I drew a nice 2. I drew a really nice 2, and it comes up looking like I don't even know what I'm doing. I'm gonna draw a better 2. I think the fact that I have like 50 tabs open might be, all right. Opposite over adjacent. So adjacent to this angle is 5. All right, that's great. All right, now let's look in quadrant 3. This is going to get a little bit, we know in this quadrant is negative and negative. So opposite this angle, you might be tempted to write 12, but you got to write negative 12 because, right, it's going down. It's negative y. I wrote a nice 2. Just go with it. Okay, that's a 2. Negative 12. Oh my God, it looks like a negative 18. That's a negative 12. It's no better. Okay. And then this is a negative x, right? So this is going to be negative 5. All right. So negative, negative. You can see how it says right here, tangent's 12/5. So you like, look, there's no negatives in there, but actually there's 2 negatives in there. So you just got to be careful. It's so easy to make the mistake of just putting 12 and 5, but you're going backwards and down. So just be careful of that. Okay, so let's just get the last one done. Let's get it out of the way, guys. Let's just do it together. Okay, cotangent is negative 12/5, negative 5/12. So then that means tangent. I'm just changing to tangent again because I'm comfortable with tangent. Negative 12/5. So again, tangent's negative. Where's tangent? So that's going to be opposite over adjacent. Okay, so where's tangent negative? Well, everything's positive here, so we don't want this quadrant, and tangent's positive here. We don't want this quadrant because we know we want negative tangent, right? So again, one of the things I mentioned yesterday is we're like, well, does that negative go with the 12? Does that negative go with the 5? Where does it go? And we'll see this momentarily. I'm going to draw the lovely triangles in. Draw it beautiful. Draw this lovely triangle. Draw my radius. Then draw your y side. Okay. All right. So I'm gonna start in this quadrant. So opposite is this side, and that's definitely a negative y. And I'm going to draw my 2 in slow motion. There you go. All right, that's the negative opposite side. And then the adjacent side is 5. And this is definitely a positive 5. These are going in the positive direction. All right, so in this case, in this quadrant, the negative went with the 12 because that's the negative direction and that's the positive direction. Now let's look at this side. And this side, the opposite side is here, and that's positive. That's gone up, so that's positive 12. And here's our adjacent side, and that's going to be negative, a negative x. Okay. Now, you know what I didn't do? I didn't find the third side. We could do the Pythagorean theorem and do the third side. It would be 13. Okay. But they both be positive because remember, hypotenuses are always positive. So if you want to go ahead and throw the hypotenuse on there, you can throw the hypotenuse on there. Okay. All right. So I'm going to tell you what I'm going to do. I'm going to come back. Oh, no, I can't come back to that screen. I want to make sure you get this written in your notes, right? Into notas. But at the same time, I want to, hold on. I want to open up the rest of the activity. And tell you what we need to do. So if you don't have this in your notes yet, hold on. I'm about to put a picture of this in the chat. I'm not as good at this as Miss Munches. She just gets it in there. Clicked on chat. Okay. Give me a second. Okay, I put a screenshot of the last one in the chat. It should be showing up momentarily. I think it's there. Okay. All right, I'm going to open up the rest of this activity. You can skip 7 and 8. Is everybody clear on that? So I only have 3 things left for you to do. Skip 7 and 8. I need you to do 9 and 10. And then I need you to promise me that you will have a safe break. I want you to take some time off, enjoy time, but don't do anything to put yourself or others at risk. I hope you all enjoy your much deserved break and that you find a way to spend time with family that is safe. And let's just all hope the stinking vaccine comes sooner than later, because I know like that teachers are sort of getting prioritized a little bit, not like healthcare workers and frontline workers, but almost like we're going to be ahead of some people because everybody knows it's important. It's so important to get back into school. It's just really going to make a huge difference. I hope you all value school and the opportunity to go to school now, now that we haven't been able to. So let's all hope that second semester can get at some point some sense of normalcy, huh? All right, so if you have any questions, you can hang back. If you don't have any questions, you are free to go. Let me, I was recording this too. Let me stop recording. Okay, so the